Good day to all. Today we can discuss about this internal circuit of operational amplifier, the subject linear integrated circuits. So this internal structure of an operational amplifier, the diagram is the schematic structure. So here, this particular internal structure is having actually three normally consists of three stages. So along with the bias circuit. So the first stage should be up to this. So the up to this, it should be called as the input stage, followed by the bias circuit. This is the bias circuit. And the third is the gain stage. And this will be the output stage. So generally, there are three sections. The input stage is nothing but the differential amplifier with the bias circuit. And the second is the gain stage. The third is the output stage. So usually the bias circuit is used to establish the bias current for whole circuit in the IC. This op-amp is applied with the positive and negative voltages. The positive voltages is of plus or minus, that is a plus or minus 15 volt, and then the supply voltages as low as plus or minus 5 volt can also be used. Maximum voltage should be plus or minus 15 volt, and it should be less than less not lesser than 5 volts. So first we can discuss about the bias circuit. So the bias circuit, the reference bias current I reference is established by the circuit consisting of two diode connected transistors. The two diode connected transistors, Q10 and Q11, we can able to establish, and the resistor used is R5 here. So, okay. So this resistor is R5. The input stage, the input differential amplifier stage consists of Q1 to this transistors up to Q8. The Q8 through this Q12 will be biasing the circuit. The transistors Q1 and Q2 form emitter followers. Q1 and Q2 forms the emitter followers, contributing to high differential input resistance, and whose output currents are inputs to the common base amplifier using transistor Q3 and Q4. Using for this Q3 and Q4, the output will be from the Q1 and Q2. This Q3 and Q4 offers large voltage gain. Large voltage gain. The transistors Q5, Q6, and Q7 along with the resistors R1, R2, R3 form the active load for input stage. The single-ended output is available at the collector. This is your single-ended output available at the collector of Q6. The lateral PNP these are the PNP transistors Q3, Q4. Okay, provide additional protection against voltage breakdown conditions. If you are using this NPN transistor, we can have up to 7 volt. And if you are using NPNP transistors, then we can have up to 50 volt protection, the voltage breakdown conditions. So this is about your input stage. Input stage is followed along with the biasing circuit. So it will be followed from Q1 to Q8, and from that Q8 to Q12, it follows the biasing circuit. Q1 and Q2 form the emitter followers, and whose output currents are inputs to the common base amplifier using Q3 and Q4. Because of using Q1 and Q2, you can have high differential input resistance, and because using this Q3 and Q4, we can achieve large voltage gain. Also, they provide additional protection against voltage breakdown conditions. As it is PNP transistors, we can have up to the emitter base breakdown voltage of about 50 volt, which is very higher. Next is the gain stage. The gain stage is followed by Q16 to Q16 and Q17 are the major ones which is used for obtaining with the Q16 acting as an emitter follower for achieving high input resistance. And this level shifting is done for this signal at this stage. What is this level shifting is a level translator, which is usually connected in a typical op-amp so as to shift the DC level at the output of the intermediate. Intermediate stage is nothing but your gain stage, which is grounded onward to zero. The intermediate stage is basically differential amplifier, which is driven by a previous state output. Okay. So by using this, what is your major? This is like a level transistor. This is your structure. Okay. So internal compensation can also be achieved. Internal compensation can also be achieved using this gain stage through Miller compensation technique is by using this capacitor which is of 30 picofarad. Here you have a capacitor of 30. Using this, we can have this Miller compensation technique here between the output and the input terminals of the gain stage. And the last is the output stage. Here the output stage is a class AB circuit consisting of complementary emitter follower pair from Q14 and between Q14 and Q20. Okay, so this is your emitter follower pair. Hence, they provide an effective low output resistance. Here, so we can achieve here low output resistance and low current gain. The output of the gain stage is connected to the base of, so if you want to extend this, you can connect to the next transistor. It is biased by transistor Q13, which also drives Q18 and Q19 that are used for establishing Q point in the between the transistors Q14 and Q20. So this is about your internal structure of a IC 741. Hope it will be helpful for you. Thank you.